Okay, let's focus in on acetal formation. Okay, in the previous videos we looked at hemiacetal formation. Now let's look at the acetal formation. Okay, so an acetal is when two alcohols, add, to the carbonyl group, of either an aldehyde or a ketone. Okay, and we're still using the acid catalyst as well. Okay, so an acetal group contains two alkyoxy groups attached to the initial carbonyl. So we're looking for something like this. Okay. So the hemiacetal had the OR and the hydroxyl group attached directly to the carbon. Here in an acetal formation, we have that carbon that was initially the carbonyl group now getting OR and another OR, so getting two of those. Okay. Now let's give this a try. Okay, so let's just say we have an aldehyde. Okay, here's our aldehyde. Okay. Now we add in the alcohol. Okay. Let's see. Oh, let's just use methanol. Okay. CH3OH. Okay. Okay, the acid catalyst. Okay. So this would lead to a hemiacetal. Now we continue to add the alcohol and we get an acetal. So we have this initial carbonyl. Now it would have an OR. Still has that CH3 there. And it would have the OR here, okay, which is that O with the CH3 from the methanol. Okay, so we get CH3, C, OR, and another OR. Okay. And both of these R's are going to be methyl. Okay. So if we expand that, CH3, C, O, CH3, and O, CH3. See, there is that not hemiacetal, complete acetal group. Right here. Okay. So whether it be an aldehyde or a ketone, we're going to add alcohol, the presence of an acid catalyst. Okay, it'll first show as an unstable hemiacetal, and then it'll continue on with that continuous alcohol into the acetal group. Okay. And those ORs are going to be directly attached to that initial carbonyl carbon. Okay, so if there is some confusion about where these ORs attach, go to that initial carbonyl carbon, and both ORs are coming in right there. Okay, excellent.